Everyone, so today is 8th May and we are live. Um, Thanks everyone for joining. So we are kicking off the Certified Meshery Contributor last study session. And in this series, we talk about how you can prepare for your Certified Meshery Contributor exam. It's the CNCF one of its kind certification. And it's more of a certification for the contributors rather than users. And the best part about it, it is completely free. So to enroll for the certification, you can find the link of the academy of our in our Meshery cloud over here, and then it's cloud.meshery.io/academy. And you can find the certified Meshery contributor certification. You can take up the exam. It's self-paced. Um, So all the recordings that we do for these meetings, they have been uploaded to the YouTube channel. You can also check out the YouTube channel from here. That is Meshery.io. You can find the videos in the live section. There will be also a playlist updated in a few days. But yeah, so kicking off the call, we have yesterday. But before that, there's a drill that we do. Please make sure that you mark your attendance in this meeting minutes. I can share the link in the Zoom chat. And we have yesterday, so it will be continuing the second part on relationships, what we left previously, and a lot of things to show around. So yeah, in the end, we also have practice questions so we can test our knowledge. So yeah. Uh, Yash, would you like to take over the stage? And he's
Yeah.
having some problem with the webcam. So, yeah.
Oh, yeah. Thanks, Ronak. Actually, it's raining heavily here, so I'm getting a power cut. That's why I can't turn on my webcam. Yeah, it's okay. Well, let me introduce myself. I'm Yash Mahakal. I'm a final year computer engineering student from Pune, India. I'm currently a GSOC intern here in Meshery. Yeah, that's all about me. And last session we were talking about the mesh relationships. We have talked about things like semantics and theoretical concepts that we have in mesh relationships. And today we'll be looking at some of the hands-on, like how we can actually create relationship definitions. What are the ways to create it? We'll be getting familiarized with something called as the integration spreadsheet. So yeah, let's start. But for your reference, you can see the slides that we have. I think they are the link is embedded in meeting minutes also. So yeah, keep your eye on this on those slides also. So let's have a quick recap what we had in last session. So talking about the mesh relationships, so the prerequisites we talked in last session was about the models. So talking about the models are actually the units of packaging for definitions of meshery. It will be consisting some of the directories and other components. For example, models are generated through source CRDs that we call as custom resource definitions. Those may live on GitHub or like Artifact Hub as a Helm repo. So yeah, models are generated through those CRDs, and they are actually logical representation of the objects in the Meshery. So, for example, Kubernetes as a whole is a model. Then moving forward, that a Meshery model will be consisting some of the components. For example, components, relationships, policies, connections, and credentials. So these are actually the units that actually Meshery models packaged off. So this is all Meshery model actually consists of. So we'll be focusing more on relationships since we are actually having this dedicated session for the relationships. Then we take a look at some of the constituents of models, like what actually makes the model. So there are some of the components. Talking about the components actually define the basic unit of infrastructure. For example, if you are talking about Kubernetes, then parts like, for example, pods, deployment, services, then ingress, then there is another things like stateful sets, daemon sets, all those things, network policies are actually the components of the Kubernetes model. And talking about the relationships, so relationships are how actually the components inside those models interact with each other, and they actually makes data flow there. So this is all about the relationships. Talking about the policies, policies actually governs the behavior and construct of the components or relationships. It is called as a rule set for those relationships, and relationships should adhere to those policies. Connections represent actually managed or unmanaged resources, which will be discovered automatically or entered manually. This is just out of scope for this session, but I'll be trying to cover it also. Talking about the credentials, credentials actually define the authentication details. For example, pulling CRDs, or like creating model from a private repository or from private link. So it needs credentials, all those things. So this is all the credentials. Moving forward, we took a look at components and then some of the types of the relationships, because relationships is not just of a one type, and relationship consists of things like semantic relationships or non-semantic relationships. Talking about semantic relationships, so semantic relationships are actually the relationships that are meaningful in terms of how Meshery manages entities and their life cycle. For example, there is actually a actual data flow, there is actual patching. So this is the semantic relationship. And talking about non-semantic relationships, so non-semantic relationships are those which are actually for just the user purpose, or are just for the design purpose. So this is the non-semantic and semantic relationship. Talking about the types of relationships, there are some of the types. For example, hierarchical relationships, sibling relationships, age relationships, or taxed relationships. We took a dive deep, so I won't be diving further into those, but for just a casual definition, so talking about the age relationship types. So kind age, this is actually a kind. We depict this age as a kind. So talking about age network, it actually configures talking about the age networking line, or like age relationships, those actually represents network or reference or other part of relationships. For example, talking specifically about age network, it actually configures networking between the components. For example, service and a deployment. Between service and deployment, it's not just a reference of service or deployment into each other. It's actually the networking rule. Since service actually forwards the traffic to the deployment to expose it on your node port, or maybe in cluster, or on your desired port. So there is a networking concepts under the hood. So that's why we call it as a edge network. Then there are some of the edge relationship types. For example, edge reference. So it is a logical or declarative links. For example, talking about instance and elastic IP. So what happens here? Here just one component refers to another by name. For example, if you're taking a look at for example, if you are taking a look at instance and elastic IP, so here the instance or elastic IP will be getting patched with the value of either instance or elastic depending on the relationships. That's what we call as age reference. Then there is a age permission type of relationship. So talking about age permission, it actually defines how components connect to establish access control. So it is for the access control. For example, if you are known about IAM controls in AWS, or any other cloud provider, or any other type of RBAC permissions. So it actually refers to the permission or access controls. So this is the age permission type of relationship. Then there is age mount type of relationship. For example, we mount storage options, for example, volumes or storage classes. We don't just refer them, we actually mount them. And when we are mounting them, it's just not a reference, it's actually they will be working alongside those resources. For example, mounting volume onto the pod. So it's not just a reference there, it's actually a whole component is stacked with that resources. So that's why it is called as a edge mount relationship. Then there is some of the other types. For example, edge firewall. So this acts as an intermediary for communications, because we know in terms of VPC or security group actually decides intelligently or smartly, like in a stateful way, that should a traffic should be allowed, or a request should be allowed to VPC or not. That's why we call it as a edge firewall relationship. Then talking about age relationship type of age annotation, it is just for the purely for the design purpose or user reference purpose. It is a non-semantic relationship. You can see those green arrows. Whenever you will be looking at the green arrows, just understand that this is an annotation type of the relationship. There is another type, that is hierarchical relationship type. So talking about the hierarchical inventory relationship, it is actually a relationship between a parent and a child component. The from array always contains the child, and the to array always contains the parent. This is the rule, and you should be noting this rule, to be honest. So whenever there is a from field, it's a child, and the to array should be containing the parent. So talking about deployment, for example, we actually mention a pod into a deployment, because a deployment can't run without a pod. It actually needs the pod to work. and that's why we have deployment, to be honest. And this is the reason it is a hierarchical inventory relationship, because we inject pod into deployment, or we can say we inject containers into pod, and that's why it is a hierarchical relationship, or hierarchical inventory type of relationship. Then there is a hierarchical wallet type of relationship. So it is just the opposite of inventory relationship. What happens in hierarchical inventory is, so it is a relationship between component where the configuration settings of one component known as the parent are combined or integrated with the configuration settings of another component known as the child. That means parent will be patching the child, but in hierarchical wallet relationship, child will be patching the parent. So this is the difference between them. And talking about the hierarchical tacit relationships, so these are when you are having the match labels field identical, then it will be there will be, for example, if you have a node port and a sample application, and if you have assigned identical labels to both of them, then it will be a hierarchical tacit relationship. So this is all about relationships. We took a look at some of the fields that we have in relationship definition that we call as a relationship schema. For example, id, then evaluation query, kind. So you can check out those slides for your reference. You can just see all of the meaning of those fields if you are joining this call for the first time and you haven't joined the call before. So talking about the relationship policies actually make sure that relationships are adhering to this, to the rule sets that we have. We have OPA, open policy agent, and then Rego engine for the evaluation. So relationship evaluation is the engine that actually validates your design against the rule book. So we have a rule book designed as per policies, and then Rego engine will be validating those your designed relationships, if they are correct or not, or if they are following all the rule sets or not. So that's all about the recap that we should be having. But now the point is how we can actually define those relationships. Since I was talking about some of the things, for example, like uh, relationship definition files, here you can find. So you will be finding all the models, components, and relationships under Meshery, then server and mesh model are directory. I'm taking a look at AWS SQS controller. So if you are going here, you can find models. This is a model. AWS SQS controller is a model. This is a version. This is the version of this schema of the schema that we are using in Meshery. You can find the component folder and the relationship folder. In the components folder, you can find the components of the AWS SQS controller, and in the relationship folder, you can find the relationships that have been defined here. Since I explained the relationships, I would like to actually explain something related to models. So yeah, let's take a look at the model schema, like relationship, what we have in model and how it is been defined. So yeah, I just wanted to make sure that if you can hear me properly or any voice problem there. Like,
Yes,
No,
we
can
can.
hear you perfectly. Yes.
yeah. All right, no worries. So yeah, talking about the model schemas. So it is same as the ID. This is for the identification purpose. It should be set at 0. A mesh server will be picking up this at runtime and will be registering it with a unique ID. This is the schema version that we use. So talking about the schema version, we have actually a repository called as the Meshery schema. So I would like to talk about the repository called Meshery schema, because it's important to actually know about the Meshery schemas also while talking about anything in the Meshery. For the formal introduction, Meshery schemas is the repository which actually holds the single source of truth for all the schemas that we use in uh, Meshery. It is like a structural backbone for the Mesheries. So if you are going here, you will be finding the schemas for the models. So let's go in models. So you can find here some of the versions. For example, we are using V1 beta 2. So you can just go here in the model and you can find some helpers here. Just see which folder it is having. Mm, Give me a minute. Schemas.
Hello.
Yeah.
Like I have a question. Uh, uh, like I had worked with this V1 beta 1 and V1 beta 3 thing, but I was not really sure like what it really actually does to the entire Meshery ecosystem. So could you kindly give a short like overview of that?
Yeah, surely I'll be talking about this. So when you're talking about V1 beta 2 or V1 beta 3, these are actually the versions of the schemas that we are using. So schema is also versioned, and I'll be talking about what schema is and how it is versioned. So if you are going here, for example, this file, this is the schema for the model that we use. For example, model.yaml. If you're going here, you can find api.yaml file 2 for the APIs. And then if you are going in the template directory, you can find model template 2. For example, a model template.json. So you can find this model template. So why I'm showing you this, because sometimes you might get confused about like what schema I should be using. So you know, now you know where to look for the exact schema. So it is the Meshery schemas repository where we'll be have all those things defined. So now talking about those schemas and talking about Sarthak's question too. So this is the schema, this is the model schema that we use for the model to define the model. For example, if you're taking a look at this ID, it actually defines it all. Everything is here. For example, this is written using open api. If you are familiar with the open api syntax, then it is written in open api. So you can take a look at this. For example, it defines all those things, just like when you are working with the Kubernetes and when you are running a command. I don't exactly remember this command, but when you are running this command, it actually gives information of all the fields that you should be using, all the spec, kind, metadata, or like what it should be. So that's how schemas is actually working. So if you are going here, you can see some of the properties defined, that what property it should be taking. For example, ID. So talking about the ID, it is giving a description of what ID is. So it's saying uniquely identifies the entity. So it is giving all those things here. So it also describe what values it should be taking. For example, if you're going in the schema version, so here is a description of schema version. For example, it specifies the version of schema used for the definitions. As Sarthak was asking about V1 beta 2 or V1 beta 3, these are the specific versions of the schemas that we used for the definition. There can be changes in the schemas there. We can iterate over the schema. So when schemas change over the time, they gets version, and that's what is V1 beta 2 or V1 beta 3. If you are this is the same thing, or if you might wonder about why the names V1 beta 2 or V1 beta 3. So these are actually the standard norms that we also use in CNC for in any field. For example, if you are going for the Kubernetes also, there are some things like beta and alpha. So this is just a general thing. It's not like Meshery is reinventing something or like is discovering something new or like that. So this is not a foreign field, to be honest. So you can then check out the versions, like what the another version field says. So it gives a description that it is for the model definition or like that. So you can just check all those things. Even for if you are going to display name, for example, we have display name defined in the model. If you're going here, you can see a display name. Let me just check. Okay, here's the display name. And just notice one thing, this one is actually a snake case, and then this one is actually like a general text. So you might say, why can we just put like this or hyphens here or not? Or like, should we like, can we do something like, okay, we just don't wanted this hyphens here, just like this. Why to put those hyphens here? So the reason lies in the schemas. So you can see here, it says that when it's about display name, it is actually a human readable name for the model. And when you can see the type, it accepts a string type. Max length is of 100. And when you are seeing the pattern, it actually defines the pattern that you should be using. That is A to Z. You can use the capital letters too, or like 0 to 9. Like this is the pattern. When you are talking about the name of the model that we have, for example, here, the name of the model here. So talking about this, you can go in the schemas and see it is defined that there should be hyphens. And then it is saying that, for example, if you're seeing the example, there is a cert manager example and there is a hyphen between them. But when you are talking about the display name, there is not hyphen. So that's the single point of truth that says why should be putting the hyphen, or why should one be putting hyphen here. And that's how it actually obeys the schema. And that's how we evaluate if the relationship or model definition is wrong or right. Then you can see all other fields, like what it accepts or like this or any other thing. It's just a huge file. You can check out it, you can check this. and you can know about it more. But now you know like what is a single source of truth and where to look for your all of your doubts. So yeah, this is about we have for the models. So yeah, this is the actually the schema for the models. Now just I think instead of going through those this code, I would like to introduce you guys with the one thing, since we have a short time of the is called as the Meshery integration spreadsheet. Now, most of you are not aware of this. What is this Meshery integration spreadsheet? But all the models that we have in Meshery are written over here in this spreadsheet, and all those models have been generated from this spreadsheet. So I just wanted to know that is it good flow that are you guys understanding whatever I said about models, components, relationships, or schemas?
Yes.
Yes. Um,
Yes,
Yeah.
so
yes.
it was a nice session overall, but could it be possible for you to actually open the application and show one of these relationships in real time? Because most of the presentation has been a bit abstract,
Yeah,
and like it would be great if I could actually like see it, like see how it works
surely.
in the application.
Yeah, yeah, surely I'll be trying to do that at the last. But now I would like to focus on like how we can create it. I will definitely talking about this also, like how we can drag and drop and how we can establish the relationships on the Meshery canvas. But that will needs me to actually run my local server, because there's an ongoing problem related to canvas since it's still working, like it's having some problems. So we'll be looking at taking a look at this also, if it's getting solved or not. So let's move forward in Meshery integrations. So talking about the Meshery integration spreadsheet is a single source of truth for all the models or integrations that we have in Meshery. Whenever we are calling as integrations, then it's the models that have been actually uh, uh, established in the Meshery project. So you can check out all those things here. Now there are some of the things defined here. For example, registrant. So let's talk about the registrant. What is registrant? So registrant is a place where all of the CRDs for your models are living. For example, this is the source of the CRDs. We know what GitHub does is we know what Artifact Hub does is. So this is the registrant, and this source URL, when there is a source URL written in this spreadsheet, it is actually a URL of those CRDs. For example, if I'm clicking on them, it will be taking me to the, and it will be just downloading the CRDs here. So let me show you how actually CRD looks and how it gets generated. So before that, if you are going here and taking a look in the components, you can see a field like source URL. So this source URL is nothing but the place where all the CRDs for this component, for example, AWS controller lives, and all those models have been actually generated from. So this actually shows you like where you can find the CRDs. So yeah, we'll be having a look at this also, but let's talk about the mesh integration spreadsheet first. So this is the mesh integration spreadsheet. There are some of the fields. There are some of the fields that you shouldn't be filling in manually. There are some of the fields that you should be filling in manually. For example, if you have to like create a model, how we can create a model is you can just go there, uh, drop the registrant name. For example, if you wanted to create a AWS Cloud model, registrant is GitHub because the CID lies on GitHub. Then you can just give a display name to your model. You can give it anything. Then for the model, you can absolutely give it anything, but just make sure to follow the conventions. For example, you should be having the dash between, that is a snake case. There is a category. Category is for the higher maintainability. You should since AWS CloudTrail is observability category, comes in observability category. It is observability tool. So we have written observability for AWS document DB or dynamic DB. You can see app definition, EC2 is provisioning. So then there can be subcategories that you can fill in. Here you should be filling the description. It's always a good practice to fill in the description. There is no compulsion that you should be filling the description, but it is highly recommended that you should be filling the description, because there are so many files, there are so many relationships, and it's useful to actually know what this kind of relationship is actually doing. So description is a must, I will say. Then there is a source URL. For example, this is source URL. You can see here for the AWS control of the CloudTrail. I would really like to show you this URL also, like what it means by CID. If you guys not familiar with the CIDs, I would like to show it. Just a minute. Yeah. So this is the AWS controllers KTS direct GitHub organization, where AWS has stored all of the CRDs for the Kubernetes. That means all of the CRDs that can be used by the Kubernetes to deploy the AWS resources. For example, talking about the well-known S3 controller, if you want to deploy S3 controller on your Kubernetes, you have those CRDs. If you are going into the Helm directory, you can find CRDs here. And once you are in the CRDs, you can find some of the CRDs like buckets, field exports, or IAM role selectors under this link. Now, if I am going in my IDE and inspecting, just a minute. And now if I'm inspecting the S3 component for now, the AWS S3 component, and if I'm going at the component, you can see where is the latest version. You can see some three components here. For example, bucket.json, field export.json, and IAM role selector.json. And if you are going to the CRDs link, this is the same buckets, field exports, and IAM role selectors. So this is the same directory, or like this is the same content, and that's how components are actually generated. So when you are putting this GitHub source URL for the CIDs, it will be generating components automatically from it, and you don't have to define the components. Then here you can find some of the access for, like example, the logos or those things. There is a primary color that you should be using. You need to give the standard SVGs here. Then if you can see some of the things like is annotation. So this is one of the important field. What is annotation? As I said, there are two things: semantic and non-semantic. Semantic are those who actually have the workflow, who actually are which relationships are actually the uh, what you can say functional. They actually patch some value, or there is actually some kind of data flow. So these are actually semantic, and talking about the non-semantic, these are just for the design purpose, solely for the design purpose. So talking about the is annotation field, if you're checking it, then it will be becoming a relationship of type non-semantic, since those models have been generated, and this spreadsheet is not for everyone's use. Only maintainers have access to the spreadsheet. I can't make a make a change here. For to make the change, I need to go here and I need to make a copy, and then I can work with it. So this is all. This is about the is annotation. Then according to publish to registry. Then publish to registry means if you want to register your model with the server yet or not. If you want to register it with registry or not, then it is if it asks, this field asks, for example, has components. So it asks if your model has any component or not. So this is if your model is having components, you can say yes. If you don't have, you can say no. Then here is some of the metadata related fields. But this is the model spreadsheet. You can see some of all the models integrated here. If you go in the bottom and switch to the next tab, you can see the components, and those components aren't hard coded, or like no one go and actually hard coded it here. Those are actually automatically generated when you have generated the model, since in the model CID you can see the already those components are sitting here. So you don't have to do that, or you don't have to mention or specify the components that you wanted to generate. They will be automatically generated. So then there is a field called relationships, which we'll be talking in this in deep and in detail. Okay, now this is the relationship spreadsheet, and this is the recommended way how you should be creating relationships. It's not like you shouldn't be working with manual way. You can create the relationships with manual way. You can write a relationship.json or .yaml file. By the way, relationship is shouldn't be only like it's not like you should be writing relationship file only in JSON format. You can write in YAML format also. It is also supported. So talking about this relationship spreadsheet, remember I'm saying now relationship spreadsheet. In Meshery integration spreadsheet, you will find tabs like models in the bottom. then components and relationships. So I'm on now relationships. You can see some of the relationships have been defined. For example, talking about AWS gateway control, or like, let's take an example of AWS RDS controller. So this is the model name that you should be defining. Then this is a version. This is a kind. Now kind, we have talked about the kind, age, hierarchical siblings. So this is a age type. Then there is a non-binding type. Type is non-binding, and then there is a network type of the subtype of the relationship. So these are the actually type, subtypes, or kind of the relationship that you can see here. Now, how they have been defined, like it's only age, it's non-binding or network, because here the components that you have defined actually to to the components that you are trying to establish relationship between. Since in AWS RDS controller model, we wanted to establish relationship between DB instance, which is a component of AWS RDS controller, and DB subnet group, which is also a component of AWS RDS controller. And since both of this are actually part of RDS controller, we have model defined as RDS controller, and the relationship between DB instance or DB subnet group is of network, and it is age non-binding type, since it's not hierarchical or like that. That's why we have this type of relationship. And then here you can actually define the relationship description also. So this is about the relationship description. You can go and actually give the relationship descriptions here in this field, and it is always highly recommended to actually fill in this description column. So actually this particular field shouldn't be manually updated or written. It will be updated automatically. But how, I'll be talking about it. So now you can, if you can go here, this field is empty. It is empty. I'll be mapping these fields to exact JSON file in later, but I just familiarizing you guys with the spreadsheet. You can see a selectors dot allow dot from field. This is the field which will be actually acting as a dictator of the direction for the relationships. So this is the field where you have to actually hard code all the schema that you wanted to define, and it depends on your knowledge of the CRDs, or your knowledge like how those two components will be interacting. And this is the selectors dot allow to field. You have to do the same thing here, and here is a selector field actually. So if you are going in the selector field, you can see some of the formulas defined there, and those formulas actually fills in those columns. Then this is the actually the file name that get generated when you use Meshery to generate this file. And here is said that generated by Golang, and do not fill in. So these results, these names, you can see these are random names, and these have been written back into the file when the generation got successful. You can see some of the metadata related fields here. The status is enabled. That means the relationship is active. You can see some of the docs, evaluation policy, or metadata. That are some of the optional fields. You can then go here in the API version, in the column called complete definition. So now this complete definition field actually holds the total file that will be generated. If you are clicking here, you can see a formula here. But if you just double click on it, it just opens a whole formula here. Now just take a look carefully at this file. Can you see this file, like this small pop that has been selected now from me?
Yeah.
Yeah. So if you're talking about this file, so you can see here is the whole schema that we use as a relationship file. Then there is written as a kind, and it is a C127. That is C in the C column. It is on 127. So if you go and in the C column, and then 127 and kind age, so this value will be automatically filled in this 127 column that was here. So this is how actually it will be filling in the file, and it will be generating then. So this is the relationship spreadsheet. And when you have to create a new relationship, what you have to do is just to copy it. You need to make a copy of it, and then you can make changes. Since this is a maintenance copy, you can't make any change to this file. And when you wanted to just create some relationships, you need to write this relationship schema here, and then you can generate the relationships. Okay, we have talked about the spreadsheet, but let's map this spreadsheet with the JSON that we have. For example, if you are looking at this field, there is a field called model, there is field called version, kind, subtype, or like this, or like selector dot allow from, or selectors dot allow to. So let me go in Meshery and let me open a relationship file. So you can see same. For example, the kind, metadata, description, is annotation. So all the fields are present here. So all the things that you're seeing there, for example, selectors allow from. So this whole thing is actually uh, defined here in this spreadsheet. For example, this you can take a look here. So everything is defined there. So this is how you can map the integration spreadsheet with the actual files that we have. So yeah, this is about the Meshery integration spreadsheet. But now let's talk about the how we can actually generate the relationships. So or generate the models, generate the components, or like how it works. So we have some of the utilities that is Meshery CTL utility that helps. You can just go in the documentation that is meshery.io. Just a minute, guys. Mesh recommendations. Yeah, in Meshery is actually documentation. You can find how you can use Meshery CTL to actually generate the models. How you can actually generate the models using Meshery CTL. Let me just find the Meshery CTL. Donna, can you help me where we have CLI documentation related to Meshery CTL?
Yeah, it's in the last reference section, extensibility and reference. Yeah, command line reference. The first.
Yeah. Oh, yeah, thanks.
Yeah.
Yeah. So there are some of the commands that you can use to actually generate the model. For example, Meshery CTL registry command that you can use actually to generate the models. For example, you can go here in Meshery CTL registry generate command, as you can see on your screen. So there are ways to generate the relationships, models, or components. So the way is Meshery CTL registry generate using a spreadsheet. So the arguments that it take is a spreadsheet ID and a spreadsheet credentials. Now, what is spreadsheet ID and spreadsheet credential? Actually, the integration spreadsheet we talked about should be live in your what you can say in a source like GCP or cloud provider, and then you can actually use spreadsheet ID and spreadsheet credential from there through the APIs. So this is how you can actually generate the models or relationships. But to simplify the things for the contributors, there is one more thing you can do, and it is actually using the CSV. So you can actually generate the Meshery models using a directory path where your CSV is leaving, or using generate the Meshery models from individual CSV files. For example, you can just run this command. You can see Meshery CTL registry generate. It will be taking flags as a model CSV. You need to discover the part to model CSV, then component CSV, then relationship CSV, and it will be generating the models. So for example, let's take a look like how you can actually generate models. For example, this is the Meshery CTL, Meshery integration spreadsheet. What you have to do is just go and download in CSV format. I have already downloaded it, so you have to download in comma separated values, that is CSV format. You have to download total of 3 files. First is model.csv, then component.csv, and then relationships .csv. When you're trying to generate a model, a component, or any or relationship, you should be knowing that you should be downloading the three CSVs locally, and then you can actually generate it. So let me work on, or let me show you how you can actually generate it. So I'll be just running a Meshery CTL command. Actually, I'm just using a alias m for that. And whenever I'm running m, it means Meshery CTL. So yeah, Meshery is running for me. So let me use it. So let's use that flag. And this is how you can use this command. So you can see Meshery CTL registry generate model CSV, component CSV, relationship CSV, and I have specified the paths where I have downloaded the CSVs. For example, in root folder, then there is downloads and models.csv, then components.csv and relationships.csv. Remember to name the downloaded files as models, components, and relationships.csv. And now here I have specified which model I wanted to actually generate. For example, I had given AWS Glue Control. For example, if I wanted to generate a model called as AWS ECR controller, CR controller. And when so what it will be doing is, since there are so many of the integrations in Meshery integration spreadsheet, as you can see here, so when if you are not specifying the model, it will be trying to iterate over it and it will be generating the all the models. But since we don't want it to generate all the models, it will be just generating a single model here. When you are running this command, it will be starting the model generation and it will be processing the things. It has actually so you can see one thing here. So sorry, I've done a mistake here. Actually, I generated, but I didn't generate them in a correct, uh, what I can say, in correct directory. But still, the command has been actually executed well. The reason why you are seeing this error is because my server was not running, and that's the reason why it is actually the error is there. But the generation has been completed. For example, it has generated one model. We asked to generate one model. It has generated total of 5 components, and then it has generated some of the relationships, and it has actually written the files to the this folder, for example /home yash and the server, but those should be actually written to the /home/yash/meshery server. So the problem I had made is I ran the command through from the Meshery directory, so we need to run it from the uh, server directory, so it will be generating the files at the correct repository. But as you can see, it has generated the relationships for the AWS ECR controller. You can see the relationship returned to this directory, and this is the file name. So let's generate another one, but now in the proper directory. So just move to the server. Yeah, I'm in the server. So let me pick any model, for example. So I can pick a model called as let's pick AWS S3 controller. So just notice one thing, that S3 controller is actually you can see here for AWS. Okay, let's generate for ECR controllers also, because I have defined relationships for it, so it will be easier for me. So AWS ECR, but now this time I'm in a directory Meshery CTL server, sorry, Meshery server. So when I'm running this command, what it will be doing is it will be generating the model and the relationships. So as you can see, it has generated all those things, and just because my server is not running, I'm getting this error. But yeah, the relationship files have been generated. Now let's take a look where it has been actually generated and where it has been actually added. So just move through it. There it has generated so many of the relationships that were defined in the file. So it has now correctly, you can see relationship returned to /home/yash Meshery server, and then the mesh models, which is the our desired directory. So now let me open my file, and you can see the green, and the green mark is the green font is because that shows that file has been modified. And the file, which file has been modified, that AWS ECR controller. You can see some of the modifications here. Now, if you're going here, and then if you're going here and taking a look here, you can see in this specific model, in this specific model. Now, a question will be arising. Okay, AWS ECR control has been modified. These versions have been modified, but not these versions. Why? Because if you are taking a look, you are knowing that when the font is in green or there's a U sign behind in front of all the relationship files, it has been actually generated latest. It has been generated currently, and that's the reason why they are in green. So if you're seeing those these two files, they have been existing here before the generation. So there were only two files, and those have been generated. If you're going into this, and if you're taking a look at these relationship files, it has been actually generated that it has actually generated the files too, but there were no any what we can say relationship exists, so it has generated a new relationship for it. There were only the components that were there, and that's the reason why you are seeing that only if you're going in the relationships also, you can see those have been modified. So, but one thing is worth noting here, relationships have been modified, but it's not like we just pass the relationship folder or relationship CSV. We even pass the components and model. So why model.json or components hasn't been changed or hasn't been modified? Reason, this component have are registered with the server. They are in the production, and that's why Meshery CTL is actually smart enough to know that okay, this model is already exists, so I shouldn't be making any changes to these models unless a new version is available. So that's why it happens there. But if you can see here, those relationship files have been generated, and if you inspect those relationship files, those are pretty accurate and pretty correct. As you can have been generated, and this you can just check, these are not actually committed anywhere, or this hasn't been pushed. So these are the newly generated files. You can take a look at them. So this is how command works in terms of relationship definition. How that's how you can actually generate the relationships. If you're taking a look here at this file, I was talking about something called as the file name. Here will be getting stored with some random names. So it's not like we really like those random names, but it is because those names have been generated with this command. You can see just those are the random names. So those random names, those files will be directly written back into this spreadsheet. If you have credentials or connections established, or like if your credentials and connections are actually stored, and that's the reason why we have connections and credentials folder in relationships also. When you are generating and we're taking a look at the slides, there's mentioned that connection and credentials folder. Reason why we have that, spreadsheet with the ID from the cloud provider, it would have written back the results. And if I had the access to this original spreadsheet, it would have written the results back to the spreadsheet. So this is how you can use Meshery register generate to generate the relationships. But for that, you have to do the manual work obviously. So if you're asking like, okay, we have to write the manual file, and then we have to do same thing here. So what's the difference? The difference is this is a single source of truth, and all the relationships that we are defining, there can be thousands of the relationships, and every single relationship should be defined in this file, and that's why we use this file to do so. Now taking a look at some of the other things, but I guess I need to just run my what I can say server here. There are some other ways also which I was working on, and actually I generated those words. By the way, talking about the relationships or this integration spreadsheet, you might say that you might see that every night we actually run a workflow in Meshery to actually update all those relationships, models, or components from the spreadsheet. So that workflow is integrated with the spreadsheet, and that's how this gets updated. Even if you are going on layer 5 website, you can see honeycomb grid, which is actually having all the integration listed and their logos listed. Their logos are also taking reference from this spreadsheet. And when you are taking a look at this honeycomb grid, it is changing its shape every day because it's just doing some of the manual doing the nightly update work, and those are the SVGs are defined from here. So whenever you come across that honeycomb grid or anything else, you should be knowing the what's actually the force behind the curtains that actually drives those things. So this is about model registry generate. There are some of the commands also that you can use. For example, I'm working on one command, but I guess it just I need to then run a server for that. I need to build a server for that. So I won't say that I'll be using that command for now, but the command, let me show you what this command is. It is a Meshery CTL model generate command that will be generating the model so it is not a command, from the local CSV. Example, it was yes. So before that, we continue. I guess next server. Okay, so I think we have a quiz also, and we are running short of time. So in the meantime, when Ronak will be handling the quiz, I'll be trying to set up the server and all the authentication, and then we can actually see the demo of those commands also, and possibly the demo of the canvas also. Like someone said that they wanted to see like how they work in the canvas also, so we can take a look there. So yeah, Ronak, can discuss about quiz also.
Yeah, thanks, Yash, for that session as well. So we have prepared some practice questions that we would be attempting live. So if you have an answer to any of the questions, you can just mention the question number and the option name in the Zoom chat. Um, I will be orchestrating these. I have 20 questions, and this is kind of a sandbox environment for the for the actual certification. So yeah, the first question is, what is a Meshery model? A runtime instance of an infrastructure, a UI only construct, a Kubernetes CRD, or a package of components, relationships, policies, connections, and credentials?
Option D.
Option D, option D is
Okay.
locked. So, what is the primary role of Meshery schema? Second question. Deploying infrastructure, storing runtime metrics, define the structure and properties of entities, manage
Option C.
credentials. Mhm. Yeah. What is the following? What which of the following correctly represents the life cycle order of Meshery entities? Schema definition, declaration, instance, instance declaration, schema definition, and so on.
I'm not sure about this. Maybe option A.
A,
Yeah, you can just
yeah, I
lock it
think
and
also.
I'll be
Yeah, I think
talking
A.
about it.
Yeah. What happens during Meshery model generation from schemas? A, only relationships are created. B, components are manually defined by users. C, components are automatically generated and grouped into models. And only policies are imported.
Option C.
C, yes.
C, okay. How are components grouped into models by default? Based on user preference, based on API version, or component size, or on a source that is GitHub repo or a head chart or the local cluster.
Yeah, I think based on the source.
I think
Yeah, I think D.
it
It's
may be D. Yeah.
yeah. Which of the following is not a type of Meshery relationship classification?
Sequential.
Yeah, A. Sequential.
What does edge relationship represent? Parent-child dependency, traffic or interaction between components, UI only connection, version compatibility.
B.
B. Yeah, B.
Okay. What is the purpose of the selector in a relationship definition? A, specify when which components can or cannot form a relationship, define a UI layout, store credentials, or define a schema version.
A maybe.
Yeah,
A. Yes. I'm not sure.
Yeah. Specify which components can or cannot form a relationship. The ninth question, what should be done after generating components in a model? Delete the unused schemas, immediately deploy them, enrich components and define relationships, convert to CRDs manually.
Option C.
yeah. Option C.
Yeah.
Enrich components.
Enrich components and define relationships.
Yeah.
10th question is, when contributing to a new model in Meshery, what is the primary source of truth for generating components? UI
Schemas.
forms, infrastructure schemas, YAML manifest, policy,
Yeah, I think it's schema.
P,
B. Yeah.
or the CRDs. Hmm. What is the purpose of component enrichment after generation? To customize inherited default policies, to delete unused components, to convert components into policies, to deploy them to Kubernetes.
To customize
I
inherited.
think option A. I think, yeah.
Which of the following best describes the definition in Meshery's lifecycle? A running resource in a cluster, B, a configured instance ready for deployment, an implementation of the schema containing specific configuration for a construct at hand, or policy applied to components.
I think C.
Yeah,
I'm
C.
a little
C.
confused about this. Yeah.
Yeah. In relationship definition, what is the role of kind? Specifying the API version, determines deployment order,
D.
identifies components.
Last
It
option.
defines. Yeah. A contributor wants to model deployment own pods. Which relationship should be used? Type should be
Um.
A.
Hierarchical.
A.
Yeah, I think
A. Next question is, which of the following is true about policies in Meshery? They're only applied at runtime. They're used only for UI validation. They define rules for governance and validation. They replace relationship.
Option
Yeah.
C.
Yeah.
yeah, C.
Next question, what is the role of policies during design time in Meshery Designer? A, it deploys resources. B, it validates the configuration against rules. C, generating schemas. D, create relationships.
I think B.
B, yeah. When contributing
Yes.
components, why is it important to align with the schema strictly? To reduce YAML size, to avoid using CRDs, to improve cluster performance, ensure compatibility with Meshery model system and UI. Yeah,
Last
Karan is the
option.
first.
Yes.
Yeah, D.
Yeah, D.
What is the key benefit of grouping components into models based on their source? A, better organization and lifecycle management, faster Kubernetes scheduling, reduced memory usage, automatic policy enforcement.
I think A.
A, yeah.
Miss
Yeah,
Meshery.
yeah, A.
All right, last two questions. How are credentials associated with connections in Meshery? One credential per Meshery instance. Credentials cannot be reused, or multiple credentials can be associated with a single connection. Credentials are embedded inside components.
I think multiple credentials can be associated with a single connection. D.
Okay, see. Some questions are the answers of previous questions. Yeah. Mhm. Thanks to Kavita. Which of the following is not a supported type of credential in Meshery? API keys tokens, username, password, TLS certificate, Kubernetes bots.
Unsure about this.
Mm,
Mm.
B,
I think D.
B,
Kubernetes pod.
not sure.
I am also not sure. Maybe D.
Yeah, I think also D, but
It's D.
Okay.
okay. Let's see what score we get. The highest we got in the whole series is 19 on 20 or just 1 point. Oh yeah, we couldn't beat the highest again. What is the
Yeah,
mystery
I think we
model
selected
UMI
option
unit test?
D itself.
Yeah, you guys
Oh
selected
yeah,
option D.
that's my bad. Yeah.
We won
Yeah,
but lost.
Hmm.
yeah, right.
Yeah. Yeah, that's a good score, I think.
Yeah.
Yeah,
So, does anyone want any explanation of any question that they have doubt they have selected just because?
I forgot
Like,
about the concept of credentials a little.
yeah, about credentials. So, if you're looking at the 19th question, like how are credentials associated with the connections in Meshery? So, when you're talking about the Meshery, you can actually Meshery is extensible and you can extend it to with any other provider, or like what you can say that you can actually use other platforms with it too. So, when you are doing that, you need to actually set up your credentials and the connections. And for example, if you are, let's take an example, if you are actually trying to connect with any database, it's not like our database, you just need to configure the password of database. You should be using the username and all the credentials that, or like that. So that's how this was question, like how are credentials associated with connections in Meshery? So multiple credentials can be associated with a single connection. And that's why the reason is that this answer is correct.
So basically, it means that Meshery allows teamwork, right?
Sorry.
So basically, does it mean that Meshery allows teamwork? Like, I'm not sure about what it means that we can
This
use
is
multiple.
This is the best and biggest feature of the Meshery. When you are looking at the definition of the Meshery, it says that it is a collaborative and it is extensible Kubernetes and cloud native manager that lets you define your infrastructure visually and collaboratively. You can have
Yes.
RBACs too, and that's why it is saying that credentials can be associated with the single connection.
So like meaning having multiple credentials, that the meaning that multiple credentials can be associated with a single connection. So it basically
Yeah,
means that we can collaborate, right?
yes, you can collaborate.
Yeah, okay.
Yeah. Any other question you would like to have explanation of? Yes, Pragalva, like it is when you're talking about credentials and connections, it is not regarding to access control or that. We provide access control in the canvas itself when you are defining your team or like that. It is about, for example, when you are actually like if you are aware of the Docker. So for the Docker, what you have to do is when you are actually fetching any private image, you have to set credentials for the Docker registry, right? So that's how it works. For example, if you are actually fetching CIDs from any private source or a private repository, you need to do that. Or like when you are actually establishing that connection between your Meshery city or like your local Meshery and with that private repository or private source, you need to do that. So that's how it works. And talking about the IAM roles, it is implemented in Canvas itself. When you are going into the Canvas, you can see that you can actually select if your design should be public or private, or like who should be having which type of access to your relationship, or like your uh, definitions or like your designs that you have defined there. For example, you can define your team. For example, if you wanted to take a number of teammates, you can take them, you can form your team, and you can assign them roles, and as per that they can actually interact with those designs. So this is about that. So let's before we leave, I just wanted to show you one more command that can use. Actually, it is in working. I'm working on it to be honest. But yeah, I would like to showcase it since we got some curious minds here. So let me share my screen again. It will be quick. Where's my terminal? Terminal. So this is my terminal, and so this is a command called as the Meshery model init. So when you are running your Meshery model init command, it will be generating a scaffold. So if I'm implementing this command, so it just here. So it will be creating a scaffold directory here. For example, you can see here, it has generated some of the directories and some of the scaffold. For example, it has, if you are taking a look, then you can see that it has created a directory. Let's see where, yeah. Let me just open my ID. In my IDE, since I run command from Meshery CTL directory, it has actually generated a new folder, like new model scaffolds. This is just a simple one, like it is not actual one. It is just a scaffold. It is like it is just unfolding the schemas. If you remember Sarthak and all, we were talking about schemas. We just saw this exact file in the schemas. So this is just imported from the schemas. You can see the relationship JSON file also as a example template. You can see credentials folder too. You can connections too, and then in the components folder, you can find the components folder too. Now, what I'm working on is we just wanted to populate those fields with actual models. And how we can do this is we can just run this command. For example, Shri CPL generate. Yeah. So for example, I'm giving a path of this newly generated scaffolds. So it is titled as new model, and it is in the same directory. So under new model, and I'm just feeding the model.json to that. And see, here is the command to actually the CRD of the Dapper. Dapper is actually one of the models. So let me just delete my generated models first. Okay. So where it will be storing the your generated models are under this .mesh repository. In under the what you can say is models directory. So let me generate this model. So my server is running. I authenticated. So if I am hitting enter here, it will be generating model for this Dapper. Just wait for 1 to 2 seconds. It will be quick.
So most of the time we have GitHub as the registrant.
Sorry.
So most of the times, like majority of the times, we use GitHub as the registrant.
Yes.
Okay.
100%. Yeah, you can see the components have been generated here. It hasn't generated the relationships because I haven't defined relationships there, and I'm not using the spreadsheet. That's why it has just generated the components. But if I go here, I was not having models directory, so models directory has been created there, and under the models directory there is a Dapper model. So if you can go to the Dapper and then just check how it has been. This is the version. This is the latest version of Dapper. Then you can see this is the schema version that we use, and then you can go here, and if you are looking at the model or JSON file, it has generated the model, and see, it has actually identified the GitHub as a registry, and yeah, you can see this. So now how it has identified that registry is GitHub, just take a look at this link. It is from GitHub. That's why. But if you are taking a look at my IDE where I have the scaffold clearly says that artifact hub. It is hard coded at artifact hub, but still it has generated from GitHub, and GitHub has been integrated here. And if you are taking a look at
I
the
think,
components also,
Yash, are you sharing your
yeah,
IDE as well? Because it's not visible most of the time.
no, I'm on terminal now.
So
Yeah,
if
I
you
mean, I
switch to
was sharing
IDE,
this. Yeah. Can you see
so
ID?
no, it's still the terminal.
Now,
No,
I guess, all right, no worries. I was just wanted to say that I haven't specified the registry there, but it will be actually smartly identifying from the link that you are given here. And now when you're in the components, you can check some of the components that have been generated. For example, you can just open any of the, for example, configuration. And you can see the component has been generated. And we had a question that after generating the models, what we should be enriching the components. Now, the meaning of that word was, or that sentence was, see, the capabilities are null. And talking about what are actually the capabilities, then capabilities defines what your component is capable of. It is actually set at null, and we need to enrich that. Now, how we can enrich that? Let me show you just a simple demo. Uh, just stopping sharing, and so we'll be sharing the screen again, I guess. Yeah. Okay. So let's take a look at my ID. And if you are taking look at the components that have been generated before, if you go here, you can find that in capabilities section, it is not null. There are the capabilities defined here, and you'll be finding these capabilities in integration spreadsheet too. So this capabilities lets you actually configure this specific components. If you set it null, you can't actually configure this component into the canvas. So that's what is mean by enriching the component. And this is what we have to do, and this is a standard practice. Now, one more thing, I'll be quick for this one also, but let's not work on it since we are up time for now. Maybe I'll be sharing my PR is open for that enhancement also. You can take a look at and you can test it. I'll be pinging everyone on Slack. So this is all I had to say. This is all I wanted to say. Yeah. If anyone have any doubt, you can ask me.
I have
Like,
one. Yeah.
what?
I have just two small doubts. One is like whenever we're creating a model, there are
Yeah.
a lot of we see a lot of version folders. So why do we have so many versions when we create a particular model?
Yes. So Meshery project is evolving from the long time, and this is the time AWS actually releases their versions, and that's why we are having those versions. If you are asking like why we are not deleting the older versions, then sometimes there can be some of the capabilities that actually useful in the current time also. So, and that's why we are having those legacy folders also. So once they have been actually totally deprecated and there is no need of them, or totally if the world has what we can say forbidden connection with those old models, we will be deleting them. That's how it works.
Okay, got it.
Yeah. Yes, Prakal, we could have, but it's already like 15 to 16 minutes about time. So I think it's good to top off. I'll be talking about that. Maybe I'll be uh, I'll be posting on discussion forum. That will be great.
Yeah.
Yeah.
So thanks everyone for joining. I think if you have any more doubts, since we have 15-20 minutes of time, you can ping Yash on the Slack channel and check the discussion forum. This practice questions, all of these things for the certified mystery contributor. There exists a subcategory in the discuss.layer5.io, and all of the things over that we have talked about, they're also present over there. And yeah, so this was the last session of the certified mystery contributor, and the series ends now. You can find all the recordings in the YouTube channel. So we'll be seeing you on Mondays that we have the websites call, and on Wednesdays we have the development call. So thanks everyone for joining. Have a great day and weekend. Bye everyone.
Thank you,
Yeah.
guys.
One more thing I want to say. If you have any doubt, or like if you have any question, you can post it on discussion forum instead of Slack. That will be better practice, and I can answer there better.
Yeah.
Yes.